Hey, welcome back to the tutorial. In this lecture, we are going to explore about FreeRTOS configuration header file. Let's say you have a FreeRTOS kernel and you want to configure it according to your product specification, or you want to optimize the kernel code size according to your application or product requirements. Okay, then there is a configuration header file which you have to use to fine-tune the FreeRTOS kernel. Okay, for example, say your embedded product doesn't require, say, semaphore or mutexes or queues, etc., then it is always better to compile out those source codes which implement the functionalities like queues, semaphore and all, and build the kernel with a very minimal functionality so that you can save some of the code space. Okay, otherwise what happens is FreeRTOS kernel will compile everything by default, which will eat up your code space. So as I said, there's a configuration header file, and let's explore that header file in this lecture. So now let's directly go to the FreeRTOS website where we can find a lot of information regarding this header file. Okay, at this link, okay, you will find an article which says customization, okay, or configuration. Here this article actually mentions all the configuration you can do for your FreeRTOS kernel, and each has a dedicated link, and when you click that link it will take you to the explanation of that macro. Okay, I highly recommend you to go to this link and read this article completely. Okay, so it will give you lot of clues, and it will create lot of doubts also. So but it is better to clarify what each configuration macros does. Okay, this header file is nothing but the collection of configuration macros. Okay, for example, consider this macro. The macro is config use underscore preemption, and it is set to 1 by default. Okay, that means the scheduling policy is preemptive. Okay, it's preemptive, it's priority based preemptive scheduling. So if you make it 0, so then it will be cooperative scheduling. Okay, so just click here so that you can read more about that macro over here. Set to 1 to use the preemptive auto scheduler. Okay, 0 to use the cooperative auto scheduler. Okay, so I have explained preemptive and cooperative schedulers in my later lectures when I am discussing about scheduler. So don't worry if you are wondering what are the differences between cooperative and preemptive. So don't worry about that. We will see that in later, but this macro is actually there to decide what kind of scheduler you want, and by default it will be priority based preemptive auto scheduler. Okay, so for example, next interesting macro is this one, config CPU clock hertz. So this will be specific to your microcontroller, isn't it? Because my microcontroller may run at 100 megahertz, your microcontroller may run at 50 megahertz, so like that. So you have to initialize this macro properly with the clock speed which you are going to use in your microcontroller. So here enter the frequency in hertz at which the internal clock, that driver, the peripheral used to generate the tick interrupt, will be executing. So don't worry about all these details. Okay, just think that the config CPU clock hertz must be initialized to the clock speed at which your microcontroller runs. Okay, all right, so now there is one more interesting macro for which you must pay attention. Okay, so tick rate hertz. Config tick rate hertz, okay, the frequency of the RTOS tick interrupt. That means this macro will decide at what frequency the RTOS timer will expire. If the config tick rate hertz is equal to say thousands, then for every 1 milliseconds your OS tick interrupt will happen. In the next lecture, I'm going to explain about the OS tick timer and why it is needed and who configures it. Everything I'm going to explain in the next lecture. Okay, so this is just a configuration macro which decides its rate. Okay. And there is one more macro. This decides the maximum priorities you can assign to the FreeRTOS task. So all these macros are actually helps you to fine tune the FreeRTOS kernel. Okay, and so I request you to go through this article. And some of the macros in this header file is architecture dependent. Okay, for example, all these macros are architecture independent. Okay. So here you can see these are the macros which are architecture dependent. So they have mentioned it as dependent on processor. Okay, so when you are porting your FreeRTOS kernel to a newer architecture or newer microcontroller, then all these things you can use as it is, but you should take care of these fields. As you make a progress in the course, you will understand more about these macros and how to fill these details. So don't worry at all for a time being. Just know that these macros are actually microcontroller specific. Okay, so you have to use this header file in your FreeRTOS kernel, because as you can see here, the FreeRTOS.h actually needs FreeRTOS config.h. And remember that FreeRTOS config.h will not be given by the FreeRTOS kernel. Okay, you have to prepare it and you have to include that in your application. Okay, when you create a project using Atmel Studio and when you add a FreeRTOS kernel through ASF Wizard, the Atmel Studio does one interesting thing. Okay, it will create the FreeRTOS config.h and it will add automatically. When you are doing code development with Atmel Studio, then need not worry about creating FreeRTOS config.h. It will create automatically. Okay, so there will be separate folder will be created called config, and the Atmel Studio will put all the configuration files of the project into that folder. So that's a nice thing about Atmel Studio. Okay, so if you are using Keel or something, then you can create yourself a FreeRTOS config.h file. Okay. Great. So all these FreeRTOS configuration and customization definitions you can read from that article which I just showed you. Okay, and understand what each configuration does. And so in the next lecture, let's explore two important configuration macros. Those are CPU clock hertz and OS tick frequency. So see you in the next lecture.